So my clock says it's 10:15. So welcome everyone, and thank you for joining DataCon LA 2021. This is the data engineering track. My name is Joanna Perdomo, your host, and our co-host today is Ruben Barrios, and together we're going to be moderating the chat and Q&A for you during this session. Today we have our guest, Anil Inamdar, and he'll be talking about understanding the open source data source primary uses and challenges. Anil Inamdar is the VP of Data Solutions at InstaCluster, and I won't take any more of his time. I'll pass it on to the speaker. Thanks for being here, Anil.
Thank you, Joanna. So good morning, everyone. Good afternoon. Hope you're enjoying the conference so far. As Joanna said, my name is Anil Inamdar, and I'm the VP and Global Head of Data Solutions for InstaCluster. The topic of my presentation is Redis, understanding the open source data store's primary uses and challenges. So let's get into it. All right, so this is kind of a brief agenda. I will talk about the need for in-memory databases. Why do we need in-memory databases to begin with? Then I will talk about what is Redis. Then we'll look at some of the primary use cases for Redis. Then I'll discuss some of the challenges. We'll do an InstaCluster Redis platform. We'll talk about that and do a quick demo. This is our Redis platform. I will share that with you. I will give you a brief overview of InstaCluster InstaCluster as a company, and then and that's about it. And if you have any questions, you can reach out to me. So let's start. So need for in-memory database. So you must have heard this term, the need for speed. Okay, and now why is there a need for speed? So the modern businesses, be it retail, high tech, finance, many more, have a need for speed. They want to go faster and faster, like the Maverick in Top Gun. So let's consider some examples. So speed and latency in retail, for example. Okay. So Amazon found that increasing website latency by 100 milliseconds led to a 1% loss of revenue. Walmart found that changing page load times by 1,000 milliseconds led to 2% gain in conversions with a similar effect on revenue as Amazon. Etsy found in an experiment that adding weight to their mobile site of 160 kilobytes led to a 12% increase in the bounce rate of people clicking away from their site. Staples changed their median page load time by 1,000 milliseconds and specifically addressed the experience of 2% of users suffering the largest delays, and they saw a 10% increase in conversion. I mean, there are several examples. I think we can probably move to the next slide. So again, similar speed and latency in the technology products. Now, Google found that adding 500 milliseconds to a search page loads decreased searches by 25%. Yahoo found that removing 400 milliseconds of delay to their pages increased traffic by 9%. So these are all significant gains or decreases. Bing found that adding 2,000 milliseconds of delay to search caused a decrease in searches of 2.8% and decrease in revenue of 4.3%. Mozilla, the makers of Firefox browser, found that removing 2,200 milliseconds of delay to a page for downloading their application increased conversions by 15.4%. One last example, speed and latency for information consumptions. Okay, so an experiment was conducted at Financial Times, and they found that adding 1,000 milliseconds of delay led to a 4.9% decrease in page views. Similarly, adding a 3,000 milliseconds delay induced a 7.2% reduction in page views. InstaCluster made a number of optimizations to the weight of their pages, which reduced wait times by 30 to 70 milliseconds, which led to a 0.7% increase in impressions. Again, an experiment was conducted with the users of the Telegraph, and it showed 4,000 milliseconds of delay caused an 11% reduction in page views. They doubled it to like 8,000 milliseconds, and the delay caused 17.5% drop in page views, and it continued like that. GQ magazine conducted an overall of their slow site and removed 5,000 milliseconds of wait time which led to 83% more traffic, 32% more time on the site, and astonishingly 108% increase in the ad interactions. So these are all pretty good numbers. Okay, we have seen this how speed impacts your revenue, your searches, your conversion rate. Now, why can't traditional databases help here? Why do we need to look at in-memory databases? So sure, like we can do several things with the traditional database like Postgres and MySQL and Oracle. We can use powerful machines, we can use clusters, we can use solid state drives. There are several configurations that we can add, we can change in the database itself to enhance the performance. But despite all these items that I talked about, in-memory databases are several magnitude faster than the fastest traditional database. So that's the big difference. Now there are benchmarks, benchmark speeds of over 140,000 storage operations under 0.1 milliseconds of on a consumer grade hardware. So that is really impressive. Now this raw speed, this advantage of raw speed enables in-memory databases to address a unique set of use cases, which the traditional databases cannot address. Okay, example is intelligent caching, accelerated user experience, adaptive traffic shaping. I will consider some of them in the future slides. Another way of looking at the in-memory databases is, I like this example of machine and degrees. Okay, so your application, which is built with say Postgres, web server, Java, etc., is kind of the machine, and it is running. In-memory databases are the degrees that make it run smoother or faster or more effectively. And I'll take another example that will make this example even clearer, hopefully. Okay, so now we saw what the need for speed and how in-memory databases can have that answer. Now let's take a look at a specific database, Redis, which is the topic of our discussion. So Redis was created by Salvatore Sanfilippo, and it was first released in 2009. Redis is the leading open source in-memory cache and database. The name Redis is derived from Remote Dictionary Server, Redis. It is often called a data structure server because its core data types are like those found in programming languages like strings, lists, dictionaries, sets, and sorted sets. So what is it? So it's obviously, it's an in-memory data structure store. It can be used as a database. It can be used as a cache. It can be used as a message broker. Some of the details about Redis. It's a cache with high availability failover. It supports distribution across multiple servers. It's a NoSQL key value data store. It uses data structures like strings, which we already discussed. What it does, well, it stores data in memory and with emphasis on speed. So that's the hallmark of Redis. Okay, it ignores everything but speed. Everything is engineered to retrieve data as fast as possible. When given a choice between integrity of data and the speed of access, Redis tends to choose speed. Some of the technologies used are like it's written in C. We can use Java, Docker, Debian, and they all work with Redis. Another feature of Redis is that it's very simple and flexible. Obviously, it's a NoSQL database, so no need for defining tables, columns, and rows. You can manipulate data with simple commands, which is very similar to other NoSQL databases. It supports multiple languages, multiple platforms, and there's a good community support. There's a litany of languages that are listed there. Again, it supports Ubuntu, Linux, Docker, Kubernetes, Oracle Linux. There's several other things you can. There's a list there. There are. It can be extended through a third-party Redis modules, they call it, and some of the examples or the popular ones are Redis Search, Redis Graph, Redis Streams. Okay, these are some of the statistics that I've collected. This is Stack Overflow Survey of 2020. In that, Redis is the 6th most used database, and it is also the 1st most loved database. So that's something. This is another survey by DB Engines. Again, in terms of the database management systems, it is ranked 8th overall. When you look at only the open source database management systems, it's 5th. And if you look at only the open source key value stores, okay, it is number 1. This is an extended list of data structures and features. We talked about strings and lists already, but there are a few interesting ones like hyperlog logs and geospatial. All right, so the primary uses or the use cases. So this is a list I have come up with. There are many others, but we'll discuss each one of them one by one. So first is speed, performance, and optimization. It can be used as a full-fledged database. It can be used with intelligent caching. It can be used with adaptive traffic shaping. It can be used as a message broker. It can be used for processing streams. We will talk about persistency and durability, and we'll also talk about scalability. Okay, so first, speed, performance, and optimization. Now, this is probably the most widely used use case for Redis. Now, on the left-hand side, there is a traditional database query. So there is an application and there is a database. In this case, it's MySQL. It could be Postgres. It could be Oracle. It could be anything. And there's a query. An application is doing a query, and it takes like 10 seconds. Now, 10 seconds might be too much for the users, and they're complaining. Now, how do we solve that problem? Well, we solve that problem by adding Redis in between. When you add Redis, okay, Redis caches all the data. So the application, when it makes a call, okay, the response is almost instantaneous, like 1 nanosecond, suppose. Now, all the data may not always be available in Redis. If that is the case, Redis does a call to MySQL, and when next time the application requests the same data, it no longer needs to go to MySQL. It's already available in the cache. So this is kind of an example of that machine and degrees. So if you look at the application and the MySQL database on the left, that's the machine. Okay, how do we make that machine perform even better or smoothly? Okay, you can add Redis as the grease, and it starts performing better. So this is one of the most widely used use cases for Redis. So it can be used as a full-fledged database also. I mean, it is rarely used to build a complex database, but yes, it can be used as a full-fledged database. It's a key value NoSQL database. It comes up with extended set of data types. We've talked about that already. It's usually in-memory database. So if you want to use that as a full-fledged database, you should be aware of that. And you should think about persistency and recovery, because if everything is in memory and the machine goes down or the power goes out, okay, you will lose all your data. So if you're using that as a full-fledged database, then you should also definitely address the persistency and recovery. And in the future slides, I will talk about that. Another use case is intelligent caching. So what is intelligent caching? Well, intelligent caching is the ability to enforce rules about how long something might be cached. What to do when the cache is full? Okay, meaning in the example that I showed on the previous slide, you can cache all the data. Okay, but what if the data in the traditional database is more than the memory? Okay, what do you do? So you'll have to accommodate pushing some data out and bringing newer data in. So that is intelligent caching. So Redis enables you to have different policies for different types of data. It has the capacity to expire data at varying time intervals. It can make distinction between volatile keys and permanent keys. Volatile keys are kind of good for eviction. So if there's a need, you can push the data out. You can configure expiration policies, adapting to usage patterns and spikes in real time. So that is intelligent caching. Another use case is adaptive traffic shaping. Now, monitoring real-time traffic and adapting to it can be extremely difficult. And it is especially difficult if the traffic is of high volume and you're using traditional databases. So in-memory databases like Redis have the speed to allow real-time responsiveness, like enforcing resource limits. An example is like 10 requests per minute per API key on the free tier, and and we'll increase that to 60 requests per minute per API key for $10 tier. And again, as the price increases, you can give better performance. You can also make architecture aware of system load. So basically, you can sacrifice non-core features to protect the core features. Okay. Again, if you're using a site like Amazon and a user has filled in his cart, and you realize that the cache or the memory is full for Redis, the cart should be the last one to be emptied, or it should never be emptied. Okay, because that's the most critical data element that you want to capture for a site like Amazon. So you can push everything else out, but not the cart. So that is kind of architecting your application and adapting to different kinds of traffic demands by the users or the applications. Redis can also be used as a message broker. Okay, like publish, subscribe, you might have heard about. So Redis allows ephemeral messaging to be pushed out in a highly efficient way. Now, those who play games, this is a very common gaming. This pattern is very common. Okay, you have a very high score, and you broadcast it to your friends and whoever subscribes to that. So the applications could write or subscribe to a channel, and if you had used Kafka, they call it topic there. So again, same thing. So obviously, Redis does not have elaborate features or functionality like Kafka. Okay, but for like but application side messaging, simple messaging, publish, subscribe, it's a good choice. Stream processing. Now, stream processing is kind of new to in-memory databases. So Redis was inspired by Kafka, and it added a robust streaming processing architecture. So it started using consumer groups who subscribe to streams of data. So it acknowledges when the data is checked out and when the job is complete. So if you need like real power, robust power and durability, okay, Redis may not be the right choice, and I would still recommend Kafka. However, Redis could be used for close to application or at the interface level to provide kind of a non-blocking experiences. Let's talk about persistency and durability. Now, it's in-memory data store, so obviously it's volatile. Okay. If the power goes out, you will lose your data. You will lose your data. If the machine goes down, you will lose your data. Okay, but there are options to write to the disk. So failover and recovery could be addressed through like snapshot and rolling logs. Scalability. Now, Redis can be scaled in a cluster mode. Okay, and it follows master-slave relationship, and we'll talk about it a little bit later. Once you start using cluster, okay, you need to start managing and supporting that cluster, which becomes critical. All right, so we looked at some of the use cases, some of the popular use cases for Redis. Now, some of the challenges. Now, frankly speaking, I don't think these are like true challenges, but that's me. I'm a little bit biased because I like Redis. These are some of the challenges people highlight when they talk about Redis. Persistency and recovery, no or limited access controls, single-threaded application, scalability could be tricky, and there is no inbuilt user interface. Let's take one by one. So persistence and recovery. So we kind of address this, but so one of the biggest advantages of Redis, why people use Redis, is because it's in-memory data store. So I don't have to go to disk and worry about the networking and the disk speeds and all those things. Okay, I don't have to worry about that. It's in memory. It's always available. That's the biggest advantage of Redis, but it could also be its biggest challenge, because if the node crashes, or if the power goes out, okay, you will lose all your data. So as we discussed already, there is a ability for us to configure Redis in such a way that we can write snapshot or rolling logs to a disk. But again, this is not a perfect solution. Okay, there are a few gotchas there we should be aware of. So that's why I've put that in the challenges section. Another is no or limited access controls. Now, access to Redis includes access to all namespaces, which is kind of a no-no if your application is kind of a security-oriented or stores confidential data. It may not be the right thing. Now, this is partly mitigated in Redis 6.0, but most of the clients I know are still on the lower versions, and this is still a problem or issue that they should consider. It's not a problem, but they should address this or use it carefully. Single thread application. Now, before version 4.0, Redis was truly single threaded, but now they're adding it, and now it's becoming multi-threaded. So one of the biggest challenge with single threaded is that you cannot use the multi-core CPU. Okay, are meaningless. Okay, you cannot take the advantage of multi-core CPU because it's single threaded. Again, as I said, it's not truly a challenge, okay, because CPU is rarely a bottleneck for in-memory database. The biggest bottleneck is memory and network. Okay, CPU is rarely a bottleneck, but there are situations where it could become a bottleneck. So to maximize CPU usage, one can start multiple instances of Redis in the same box and treat them as different servers. Again, this is just a workaround. As I said, they have started using multi-threaded, but if you are using version before 4.0, then it is truly single-threaded. And if you do need to use multi-core CPUs or the CPU more effectively, you can spin up additional Redis instances in the same server. Scalability is tricky. Now, Redis can be used in two modes. Single instance or a cluster mode. So for single instance, the single instance must be brought down for changing the configuration. Cluster mode is scalable, but those who have used systems like Cassandra or Kafka, the scalability is kind of seamless. It's fairly automated. For Redis, it's kind of semi-automated. It's not as robust, as user-friendly as Cassandra, I would say. So therefore, I've added that as a challenge. It's not a big challenge. No user interface. So it does not have inbuilt management console. So if you have used systems like React or MongoDB or any other modern systems, they have a management console. Here, there's no management console. It relies on open source software solution. So the operations teams must rely on command line interfaces. Again, it's not a big deal according to me. So the Instacluster's Redis platform, our Redis platform. So let's take a look at that briefly. So now, before jumping into the Instacluster Redis platform, I want to kind of go a little bit deeper into Redis clustering so that we get a good idea when we look at my platform. Instacluster platform. So a cluster is a collection of 3 or more nodes. A node can have 2 roles. One is master node. So master node services all writes. It also acknowledges writes. It also replicates data to all replica after the write acknowledgement. It can service both write and read requests. The second type of node is replica node. It replicates only a single master node. It can service read data request, but not write data request. So that's the difference. Okay, now this is our platform's clustering topology. Now each node has a single role, master and replica. All nodes are of the same size. So we have simplified a few things. Each node has equal number of shards of data. Now customers can configure the cluster the way they want. But if the cluster is provision without sufficient replica, it cannot be called a production cluster, and it won't have the same SLAs. Now, this slide explains our cluster failover scenario. So if a master node fails, the remaining nodes will elect available replica and promote it to master. Meanwhile, the fail node is serviced and replaced. It joins the cluster as a replica node. The visual on the slide kind of explains that, and there are 5 steps. Okay, let's start with step 1, and I'll go through it quickly. We are still 5. Okay, yeah. So in step 1, cluster is in operation. Step 2, master fails. Step 3, master is unresponsive. Step 4, replica is promoted to master. Step 5, fail node returns as replica. So that's how we handle failover. All right. So before continuing with the further demo, I just want to do a quick demo. It'll take like 2-3 minutes. It'll give you a good idea. So this is my. You cannot. Can you see it or not? I'm logging in. Sorry. Few seconds. Oh, wow, I just logged in 5 minutes ago. Okay, if it doesn't go, I'll just move forward. All right. So I think sorry about this. I'm having trouble logging into the demo. I just created a cluster like half an hour ago. Let me give one more try. All right. Okay. So sorry about that. I think so. We are in. So if you want to create a Redis cluster, so I think. I'm going to show you how to create a Redis cluster, but you can create all kinds of clusters that you want: Cassandra, Kafka, Elasticsearch, Postgres, Zookeeper. So first thing we need to do is give it a name. So I'm going to give it a name, Redis LACon 2. I've already created a Redis LACon cluster yesterday because it takes 5 minutes. I don't want to waste time. So let's call it a non-production cluster. We can have this cluster on any of the platforms: AWS, Microsoft Azure, Google Cloud Platform. Let's go with AWS. Okay, now here, what did I do here? Sorry. Okay, sorry. So I need to select Redis. Give it a name, LACon 2, Redis, AWS. Go next. All right. So basically, there are data center options. Right now, it's in US West Oregon, but you can select that and choose whatever you need. I'm creating a simple 3-node cluster, 3 master node, 3 replica nodes. Now there are different node types. Okay, node sizes. Okay, you can use. There's a list of node sizes that you can choose from. If a particular one that you're looking for is not here, you can add that. Okay, but we'll take the default one. Okay, and go to next, and that's it. Basically, if I say acknowledge and say create cluster, it'll start creating the cluster. Okay, and so I'm not going to wait. It has started creating the cluster. I'm not going to wait there and show you the existing cluster there. So this is the cluster that I created yesterday. So there are 3 master nodes, there are 3 replicas. You can look at the monitoring. You can look at the CPU usage, disk usage, operations per second, memory usage. It can be, you can go as granular as you want, 15 minutes, 1 hour, 3 hours, 1 day, 7 days. It'll keep on changing. Right now, nothing is happening on the cluster, so not very interesting monitoring, but I'm just trying to show you how easy it is to look at this. This is the details of the clusters. These are the firewall rules. If you want to set up, you can set up VPC and add VPC connections. This is a connection info if you need. If you want to start backup, you can do that. If you want to add nodes, you can do that. And the bottom line is that it's a fairly easy way to start a cluster. In like 5 minutes, you will have a cluster on either Amazon or Azure or AWS. And there's an on-prem option too, but you will need to contact our tech ops to enable that. But anyway, I think it's a simple demo of how easy it is to create a Redis cluster. This is the Redis con, which I just started. It is provisioning, so it'll take like maybe 4 or 5 more minutes to run. But the idea was to just show you how easy it is to deploy a cluster. Let's go back to the original slide. All right. So let me give you a quick overview of the Instaclustr. You saw our platform. So we focus solely on 100% open source technologies, and the technologies that we support are at the bottom of the screen: Cassandra, Kafka, Elasticsearch, Redis, Spark. We also support Postgres. I should update this slide. On the top, we have the services that we offer: consulting, support, and managed platform. In the middle, what we have is what differentiates us. So we provide full life cycle support. So right from strategy to architecture, to development, to implementation, to training, to support, to manage platform if necessary. 100% open source, I already said that. No licensing, no lock-in. Operations first. So we are not the people who wrote Cassandra or Kafka or Elasticsearch or Redis, but when it comes to operations, we are pretty good at it. In fact, for Apache Cassandra, we are the #1 operators in the world. We also provide certified and tested builds. We also fill gaps from open source ecosystem. So I said that we are operators first, but when it comes to bug fixes or patches, we have written several patches and used and worked with the community to upload those patches into the software. We have written over 100 patches so far. So that's how we deliver. This is our platform. So you saw the Redis overview. It's very similar for all the other technologies. On the top, I have all the technologies that we support. In the bottom is the platform: AWS, Azure, Google Cloud Platform, or on-prem. And in the center, we have all the services that we provide with our managed platform: provisioning, monitoring, scaling, security, backup and restore. So if we start managing your clusters, we will do all this for you, and you can focus on your business use case. A quick company overview. We were founded in 2013, so we're kind of a startup, but it's a profit-making startup around 8-9 years. We started in Canberra, Australia. We have over 100 employees. It's close to 200 now. Our headquarters in Redwood City, California. The 24/7 tech ops and development team is in Australia and also in US. We have over 300 customers globally, and many of them are household names: DoorDash, FedEx, IBM. All right, and this is a special promotion. I wanted to relay that to you. So we are offering a 2-hour free open source consulting advice and 1 week free access to Instaclustr Redis platform. So basically, you can spin up 3 node clusters in 3 to 5 minutes. I'm saying Redis platform because this is a Redis presentation, but if you need to spin up Cassandra or Kafka cluster, you can do that. Just mention LI DataCon to get the above promotions. So I think that was the last slide. Hope you enjoyed my presentation. If you have any questions, you can reach out to me at anil.inamdar@instacluster.com, and I will take your, I will respond. If you go to instacluster.com, if you want to find out more, we do have a white paper on Redis, a couple of white papers. So if anybody needs that, reach out to me and I will share those with you. With that, I will probably hand it over back to Joanna. Thank you so much.
Thank you, Anil, for that wonderful presentation. I hope folks made note of that special promotion. So now we have about 5 minutes left in the presentation, the session. So if anybody has any questions, feel free to drop them in the Q&A, or if you want to show any gratitude or insightful things that you appreciated, also drop them into the chat. So right now it looks like there's one question. Do you find that certain industries are more likely to adopt Redis, for example, retail or gaming versus healthcare or defense?
Yes, so that's a good question. And our experience is that gaming is one of the heavy users, and we have Epic Games is one of our clients, and they use Redis. Retail is definitely huge. Okay, I think any web application, okay, Redis is a good use case. Yes, and I would say that the applications that have a kind of a front end where there's a user interaction, Redis is a great choice. But most any other application, even if the user is not interacting, okay, we can use Redis to perform it better. That machine and grease thing, okay, the grease is useful for any kind of machines. Yep.
Are there any industries that are maybe hesitant to jump on the Redis board? Because it sounds like a great product. I'm a fan, but I'm wondering if there are industries who are really hesitant for there's no need.
Yeah, so I think I don't know if there are financial industry folks here, but financial industry is always very careful. Meaning it took them some time to adapt like public cloud, okay, and it's still they're not there. With Redis, okay, because everything is in memory and the access is not that well defined, okay, so they definitely are cautious. Okay, there are many. I gave you a few examples where financial industry was using it, but yes, they are very careful. And as it evolves and the ACLs are become more mature, okay, they will start adopting it. But I don't think it's industry agnostic. Okay, it can be used anywhere.
So if folks have any other questions, please drop them in the chat. But at the moment, it doesn't look like there are any. There's a few minutes left, so Anil, I wanted to open up the floor to you if there was a final message that you wanted to leave folks with before we close out the session.
No, I think I would say that enjoy the conference and share any feedback that you may have on the presentation or our Redis platform. Make use of the promotion. We can give you 2 hours of free consulting. You can spin up Redis Cluster or Cassandra cluster or any other clusters. Play with it, and if you need any questions, reach out to me. Explore our website instaclustr.com. That's about it. But enjoy the conference, more importantly.
Wonderful. So no more questions. So we're going to close it off and give everyone a few more minutes of their time. So thank you, Anil, again for your presentation.
Thank you so much.
Thank you. Yeah, thank you to the attendees for the question. Yeah, it was fun. It was great to hear about the good work that you and that Redis is providing.
Thank you.
You can contact the speaker directly. The slides are also available down if you wanted to reference them at a later point. And please just provide any feedback on the form that we'll leave in the chat box. Ruben will drop that in shortly. And thanks again, everyone. Enjoy the presentation.
Thank you.
And thank you for coming to DataCon.
Yeah, thanks.